this will work out just fine. What we have here is a mess, just straight up mess. This door is a Piper door, Piper aircraft. I don't know what the hell it is, something, I forget. Can you see that? This door is at an airport when a hurricane went through, and it sucked open the door and it bent it here. This door had been patched at some point, and here's the patch. It comes around here to here, but the patch here, somebody put bondo over top of it. It's not really the way that we want to repair sheet metal. So what we're going to do to this door, we're going to remove the existing repair and we're going to repair it right. We'll get rid of the bondo, fix what we need to fix, straighten this. I'm not going to get into the paperwork that's going to be required to make this repair. I'm not going to get into the logistics of all the paperwork. We're just simply doing sheet metal techniques, stuff that you can use for experimental aircraft. Who knows what reasons you'd have for doing sheet metal work, but all of these would just be basic techniques and steps involved with doing sheet metal work. All right, first thing we want to do is get rid of this bondo that somebody put in here. As I was saying, bondo doesn't really stick to aluminum very well, especially as thick as this is. Either way, aviation and sheet metal, we don't use bondo. Even if this is an experimental aircraft, to where it'd be perfectly legal to use bondo, it's still not a good practice. Okay, I got enough of the old patch exposed. You see it following this line right up there. This is the bulk patch. This is the original skin. And if the camera will focus right here in this bend, there's a hairline fracture, a crack. So this patch through here, it comes up to here and around. See if you can see that. All this is going to be removed. I don't care about this patch. I don't care if it gets destroyed. I might save it as a template to retain these rivet holes, especially because it's got a hinge. I want to relocate this hinge so that I don't lose this position. But as far as scratching this up or tooling marks on this aluminum, this patch, I don't care. This is going to be thrown away. So I'm not going to be real careful with this patch, the old patch, because we're replacing it. These rivets that attach this patch is just around the perimeter of this patch. Look at the inside of the door. These are the shop heads of the rivet. I'll be able to get to all these fairly easily. And of course, there's a crack. We're going to put a doubler on that and fix that. We'll address that later. These are flush rivets. Fairly simple process. Automatic center punch. I'm going to center punch mark these rivets. Find the center so it's easier to drill them. mixed, I do have a couple fours, number 4 rivets in here. So I'll have to get a number 30 drill bit for these number 4s. Number 4 is an 1/8 inch rivet. I'm going to skip over some of the basic rivet nomenclature. I'm going to assume that if you're interested in this, you already have some basic knowledge about aviation hardware and rivets and alloys and flush rivets versus the 427s versus the 470s, the button heads, you name it. All right, there's another one here that I didn't quite get all the bondo off. I can feel the shot pad on the bottom side, but I can't see the head. So I'm just going to chisel a little bit more of this bondo off. Okay, part of doing this sheet metal work is looking at the component, looking at the sequence of how it's put together, understanding the assembly process, and thinking about the sequences, the steps that you're going to use to make the repair. Oftentimes a component that is broken was installed on the assembly line at a stage, and then thereafter, let's take a wing for example, an extrusion could have been attached to the wing spar, to a rib at some point, and then the top skin could have came over and riveted and closed it out. That's a sequence that oftentimes to repair, you don't have the luxury of backing up time and undoing the sequence to have the proper sequence. So there's a strategy, how can you make the repairs, and how far into the material do you have to open it up to gain access. Whoever did this repair prior should be able to see it here. This hinge, there's access to the back side of this rivet and this rivet only. Simply come around here on this flange and there's access to the shop pad area of the rivet. These 4 rivets, there's no access. It's inside the door jamb, the molded stamped door jamb. So what the previous mechanics have done, let for the camera to focus. There we go. This rivet here is a solid rivet that can be squeezed because there's access to the backside. Same with this one here. These 4, 2 here and the 2 on the reciprocal side, there's no access to the backside. So if the camera will focus, you can see that these are actually a type of pull rivet. I don't believe they're Cherry Max. I don't see the lock. I'll take some of this paint off and verify, but they are a pull rivet of some sort. So once I get a little bit further in, I can see, but take a note, this hinge is going to go back on the same way. I will use a structural rivet, Cherry Max rivet with 2 locks, to ensure that this has proper strength. All right, I don't know what kind of rivets they were, but they're not Cherry Max rivets. They're not what I would consider a structural rivet. I put the automatic center punch on them, half dozen clicks or whatever, and the mandrel came right out. If it was a Cherry Max rivet, it would have a locking device on the center mandrel. See if I can get another picture. Okay, there's a good picture. You can see the shadows of the center hole where the mandrels just fell right out of the rivet. So now it'd be very easy to use that hole that's in the center just to drill out these heads. Now the rest of these are solid rivets. I just drilled out these 3 rivets and knocked them through just enough to where I could get the hinge off. The balance of the rivet is still left in the base material. It's still in the skin and the substructure. You can see where it was replaced before. You can see that hole was not quite where it needed to be. That's referred to in the industry where people call that a snowman, because the 2 holes adjoining each other resemble a snowman. Again, this hole's nasty. That hole's not bad. That hole's not bad. These are pull rivets. You can see the hollow where the shank was has been removed. These will draw out fairly easy. Now these flush-headed rivets, let's see if I can get the camera to focus again. There we go. You can see I'm just drilling through the dimpled part itself. I want to take the dimpled part out. I don't want the drill bit to go down through the base metal. I don't want to end up doing a snowman hole like the previous repair. If we drill out a rivet properly, use an impact punch, a few impacts, a few snaps with the impact, a lot of times we'll break it. See how the head popped off? That's what we want. Just for the flush head of the rivet to pop off. And we push that down, you can see where I drilled through, and if you look at the hole, the flush hole, the drill bit did not compromise the integrity of that hole. It's still perfectly round. If you get one like this to where you hit it a couple times and it doesn't come off, just lightly touch it with the drill bit. Don't want to remove a lot of material. You can see there it looks like the head's already starting to come up. Let's see what this one does. Start here, better than here. See how it popped right up? That's what we're after. The rivet is still in the hole, and the integrity of the hole is still nice. Let's see if this one pops loose. Yep. might be able to see that there's a whole lot more holes in this base metal than there is in this old patch. Alright, as you can see, I got a lot of damage here to this door. Okay, all these are Cherry Max rivets. I see the lock in them. Okay, these cherry rivets, like this one here, it has a steel mandrel inside of an aluminum or an aluminum alloy rivet. These I'm pretty sure is aluminum. I'll know as soon as I put the drill to it. There's a steel mandrel inside of it, and then there's a snap ring, a locking ring that locks the mandrel into the rivet. So what I've done on this rivet here is I ground the top of the rivet out to release that round snap ring, that lock device that locks the mandrel into the aluminum. So now that that's gone, it's been cut down, I should be able to take this drift and just poke through and poke that mandrel right loose. If I can show you a picture, see if I can get the camera focus. So I took these cherries, ground down the head to release the lock. See where I ground into the head of the rivet. Very careful not to get any tooling marks in this base metal. And then just a few little light taps and that mandrel pokes right out. What works really well for these is to take a chisel, a wood chisel, and I like to turn it upside down and just catch that lip, just slide it off. See if we can demonstrate. See how it's coming off, peeling up, being very gentle with it. Just light taps. Just light taps. I don't want to hit this very hard because it will deform the substructure. You can see I have a big crack right here. I'm gonna have to do something with that. Now to speed the removal process up, I'm going to use this hole where the mandrel previously was as a drill guide. Just to remove some material. So on this side of the frame, we have the heads removed from all these cherry max rivets. This side here, this is the shop head of the rivet. These shop heads are very accessible. And with this pair of side cutters that I have, you can pull the rivet up out of there. This is a steel plate